So an equation which involves one dependent variable and its derivative with respect to one or more independent variables is called a differential equation. Okay? Many of the general laws of nature in physics, uh, chemistry, biology, and astronomy find their most natural expressions in the language of differential equations. Okay, so applications also uh, abound in mathematics itself. Okay, so if we have y is equal to f of x, y is equal to f of x is a given function, then its derivative will be dy by dx, okay, and can be interpreted as the rate of a change of y with respect to x, with respect to x. So the variables involved and their rate of change are connected with one another by means of basic scientific principles. So that governs the process. Okay. So we know that the force, right, F is equal to m into A, okay, where m is some constant. Okay, so acceleration is dv by dt, that is the rate of change of velocity, the rate of change of velocity. So velocity, which is dy by dt, that is the rate of change of position. Okay, so we get force equal to m into d square y by dt square. Okay, now an ordinary differential equation is one in which there is only one independent variable, so that all the different derivatives occur in it are ordinary derivatives. Okay, so say that. Now a differential equation of the form which is a n d to the power of n y by d x to the power of n plus a n minus 1 d to the power of n minus 1 y by dx to the power of n minus 1. Okay, and we have a2 d square y by dx square plus a1 dy by dx plus a naught into y is equal to f of x. Okay, so this where an minus 1, a2, a1, a naught, and f of x, these are the constants. Okay, and f of x is a function of x alone. Okay, is called as linear differential equation with the constant coefficients. Okay, you are saying these are the constant coefficients. Okay, a naught, an minus 1, a2, a1, a naught are the constant coefficients. Okay. So right? Yeah, okay. The
Yes, sir.
function of d into y is equal to f of x. So let us solve d square y by dx square minus 2 now this is of first order differential equation. Okay. So this one, so we got yc as c1, okay, and this is yp, which is yc plus yp, which results to as x square plus c. So we got y is equal to x square plus c1 as the solution of the given differential equation. Okay. So let us solve y double dash minus 5y dash plus 6y is equal to 0. Okay. Which is nothing but d square y by dx square minus 5 dy by dx plus 6y is equal to 0. Okay, now this will be d square 5 minus 5d plus 6y is equal to 0. Or you can write d square minus 5d plus 6 into y 0. Okay. Now this is in the
Yes,
form of f of d into y is equal to 0. Okay. Now the given
yes, sir.
equation we have write in the auxiliary equation, which is replacing d as m. So this will be m square minus 5m plus 6 is equal to 0. So we got for d square minus 5m plus 6 is equal to m square, okay, 0, where we got minus 2 and yeah, which is equal to 0, right?
Yes, sir.
Now we got m value as 2 and 3. Okay, so y will be c1 e to the power of 2x plus c2 e to the power of 3x. So this will be the solution of differential equation. Now let us look at another problem. Let us solve d square y by dx square minus 2 into dy by dx minus 3y is equal to 0. Now let's solve this. So this will be d square minus 2d minus 3 into y is equal to 0. Okay. Now the auxiliary equation corresponding to that will be m square minus 2m minus 3 is equal to 0. Okay. So right, we will find the roots now. Now that we got n plus 1 and n minus 3, right? Equal to 0. So n is equal to minus 1 and n is equal to 3. Okay. Again, the roots are real and distinct. So yc will be c1 e to the power of minus x plus c2 e to the power of 3x. Okay. And that we can write as y is equal to c1 e to the power of minus x plus c2 e to the power of 3x. So this is the solution of the given differential equation. Okay, now let us solve d square minus 2d plus 1 into y equal to 0. Okay. Again, the auxiliary equation corresponding to this will be m square minus 2n plus 1 is equal to 0. Okay. So we got the roots, which is m minus 1 whole square, which is equal to 0, or the roots are m 1 comma 1. The roots are real and repeated. Okay, so our complementary function yc will be c1 plus c2x into e to the power of x, and the given solution will be y is equal to c1 c2x into e to the power of x. Okay, now let us solve d cube y by dx cube minus 6 d square y by dx square plus 11 dy by dx minus 6y is equal to 0. Okay, so this will be d cube minus 6d square plus 11d minus 6 into y is equal to 0. So the given equation can be written like this. Again, the auxiliary equation will be m cube 6m square plus 11m minus 6 is equal to 0. Okay. So that is m is equal to 1, 2 and 3. Okay. So we got m minus 1, m minus 2, m minus 3 is equal to 0. So 1, 2 and 3. Okay. So yc will be c1 e to the power of x, c2 e to the power of 2x, c3 e to the power of 3x. So y will be c1 e to the power of x, c2 e to the power of 2x, and c3 e to the power of 3x. So this is the solution of the differential equation. So let us solve d cube y by dx cube plus y is equal to 0. Okay. Now this is d cube plus 1 into y is equal to 0. Of d into y is equal to 0. Now the auxiliary equation is m cube plus 1 is equal to 0. So this will be m square minus m plus 1 is equal to 0. And we already got one root, that is m plus 1. That is m is equal to minus 1. Now that we got the roots, m as minus 1, 1 by 2 plus or
1
minus
by 2 plus or minus
1 by 2i. Okay. So yc will be c1 e to the power of minus x plus x plus 1 by, sorry, this is c2, since we have alpha as e to the 1 by 2, so this will be e to the power of x by 2 c2 cos root 3 by 2 x plus c3 sine root 3 by 2 x, and y will be c1 e to the power of minus x e to the power of x by 2 c2 cos 3 by 2 x plus c3 sine 3 by 2 x. So this is the solution of the given differential.